Let's take a moment to talk about sets of numbers. Whole numbers are going to be like counting numbers, 1, 2, 3, infinitely continuing, but whole numbers include a whole. They include 0. Now integers, I'm sure you're thinking, oh, those are negative numbers. Yeah, they are. -3, -2, -1. 0 is included in there, and then 1, 2, and so on. So another way of thinking of integers is it's all whole numbers and their, how would you say that? All these whole numbers and their opposites. Or another word is inverses. Closure is a new term. Let's talk about closure. Closure has to do with the fact that you can get an answer to a certain operation in a system. So let me give you an example to help you understand closure. In integers, subtraction, I'm dealing with all my integers and I'm subtracting. So in integer subtraction, you do -3 minus 5. And if you know your integer work, you can change this to addition of the inverse if you want, but you'd get -8. So is -8 an integer? Yes, it is. So this system has closure. Now, contrastingly, what is different is think about whole numbers subtraction. That's groovy when I do 10 minus 3 because I get 7. This is a whole number, 7. That works. What if I do 116 minus 20? That gives me a whole number, so yes, that works. But what happens when I do 3 minus 10? In my mind, I get -7. It's not in the system. It's not a z system, so I don't add or subtract some number to get back in the system. So this system does not have closure. And that kind of, for our purposes, just makes it so that we don't want to hang out with it. We're not going to even dabble with it because it doesn't have closure. It's kind of like unfinished. So let's test whether a system has closure. Let's think about this system here. How about z? Ignore the yellow, but z, what system is this, first of all? Z5, multiplication. Does this system have closure? In other words, every time you operate, can you find a answer that lies within the system? Any of these, are all of these cells filled in? Yes, so this has closure. It's true, when you do 4 times 4, you get 16 and you are out of the system, but you know how to get back in the system. Actually, you should subtract 5. So 4 times 4 is 1. See, there we go. So yes, this system does have closure. Let's think about whole numbers division. Okay, whole numbers division. So 4 divided by 2, cool. I got 2, that's a whole number. But what about 2 divided by 4? That's a half. Now, is 1/2 a whole number? No, whole numbers are wholes. You cannot have halves. You do not have fractions. So whole numbers division does not have closure. But you know what does have closure? Think about what operation you need to use with whole numbers to have closure. So what needs to go right here? What operation does indeed have closure when you use whole numbers? There's 2 options, actually. The answer is it could be addition, or it could be multiplication. Whole numbers addition and whole numbers multiplication, they do have closure.